In this session, we will discuss about simulation of smart traffic, smart vehicular networks with open source toolkits. For implementation of such type of scenarios like VANETs, vehicular ad hoc networks, Internet of Vehicles, IoV, generally some classical platforms are used like MATLAB, Scilab, NS2, NS3, Vailenta, Qualnet. Earlier, if we move back to 10, 20 years, then one platform was very popular, that was Glomosim. Okay, but when when we cover or when we simulate our implementation on classical tools on classical platforms like ns2 or ns3, what is major problem? You might have seen that as far as ns2, ns3, omnet, these platforms are concerned, many times we stuck in recent protocols. Nowadays, so many recent protocols available, so many new IoT protocols are deployed, and it becomes very challenging how to integrate MQTT in NS2, how to implement advanced protocol, how to implement 5G in NS2, NS3. I want to work with Internet of Vehicles, IOV. Actually, earlier you might have seen researchers were working on VANETs, vehicular ad hoc networks. But nowadays, VANETs are transformed to IOV, that is Internet of Vehicles. That is a type of IoT scenario. So, if we want to work with very realistic implementation for Internet of Vehicles, then rather than using NS2, NS3 or classical toolkits, we can make use of very advanced libraries for simulation of internet of vehicles, very effective multi-featured platforms for simulation of smart traffic. If you are working on smart city, if you want to work on smart vehicular control, so multiple toolkits available. So you can see that, for example, so some platforms I'm showing you here. City Flow is there, Eclipse Sumo is also there, and open source. You can see open source simulator for autonomous driving research. Okay, you want to work on some research scenario on drones. Okay, in NS2, NS3 drones, it is very challenging. It is very difficult how to simulate drones, how to simulate robots. Okay, city flow. So multi-agent reinforcement learning based environment, and most of these platforms are completely free and open source. And if we want to work with advanced VANET based application, advanced vehicular network based application, then we can work on it. Sumo. Okay. So you can see Eclipse Sumo. Real time traffic monitoring, real time analytics of data. So in this way, for example, I want to show my vehicles in this particular format. Okay, in Google Earth, in form of Google Earth, Google Map. In NS2, this type of interface is not available. I want to put number of vehicles, different types of blocks, different types of crossroads. On those crossroads we want to put some traffic light, we want to put a pedestrian path. Okay, so we want to work on very realistic implementation. For example, uh, associated to a particular longitude, latitude. Okay, I want to take a particular crossroad or a particular traffic light in Chennai or in Bangalore. Okay, a particular metro city longitude, latitude I want to capture, and real time map I want to integrate in my scenario, that whether my implementation is effective or not. For example, I am working on congestion control. So I want to see whether my congestion control algorithm is implementable in Chennai or not, in Bangalore or not. rather than hypothetically. In ns2 ns3 other simulators, we create some hypothetical scenario, we create some diagram, we create some lines. On those lines, on some virtual crossroads, we put some vehicles. Okay, we intentionally put some congestion. Then we try to show that this particular congestion is getting removed or getting controlled with my algorithm. So everything is in our control. So to some extent, we want to take a scenario that is not in our control. I want to take a particular location from specific city, from very congestion based scenario. Okay, from a particular location which we think that it is very busy, it is very the lots of crowd, lots of traffic is there. So that particular scenario we want to implement. For that, there are number of simulators which are providing us interface to Google Earth, Google Map. Okay, so autonomous driving, vehicular communication, traffic management, multimodal traffic network import, and everything. Traffic lights we can put, real time interaction, traffic control interface. So we will be able to work. Eclipse Sumo, city flow. So you can see that this one, or you can work on so many platforms, and these are available in free distribution. AirSim, okay, AirSim is available, or this one. Okay. So such type of very realistic implementations we want to perform. So this type of implementation I want to show in my research work. Okay, similar to a video game. Okay, so if we want to show this type of scenario in our implementation, in our demonstration, in teaching, learning, or as all of you are academicians, you also might be delivering, you also might be writing research projects or research papers. Many times we have to show in a realistic way. So if this type of crossroads are there, if these types of lines are there, whether our algorithm will work or not. So for such type of implementations, what we can do, we can take very powerful platforms, very dedicated platforms, CityFlow, Kerala, Eclipse Sumo, or CupCarbon. And one more platform I'm showing you, Mosaic. Okay, that is Eclipse Mosaic, dedicated to smart vehicular communication. You can see multi-scale simulation framework, and all of these are completely free and open source. Product of Eclipse, everybody knows that product of Eclipse are very powerful. You can see that what we can do, mobility applications, intelligent connected applications. So IoT scenarios we can create, traffic. We can integrate smart public safety. We can integrate electric vehicles. Nowadays we are in the era of electric vehicles. So we want to show some vehicles on classical fuel, some vehicles on electric vehicles. Okay. Then what is the performance? So green mobility solutions. So these are new areas of research for the papers, for research projects. Okay. Smart traffic management, collaborative driving, and it is completely free and open source. Okay, whether you want to work on electric mobility, flexible traffic management, mobile applications, smart public safety, pedestrian roads, or any other, Eclipse Mosaic. In this session I will show demonstration of these tools on multiple scenarios, by which way you will be able to work. Okay, these tools are very very powerful, lots of features available, whatever you can think. For example, you are working on some particular scenario like smart vehicular communication with machine learning, smart vehicular interfacing or internet of vehicles with deep learning, internet of vehicles data you are capturing from the simulation, and you want to perform some AI based approach, so that you can do. So integration of AI with vehicular communication. So lots of opportunities available in this segment for publication of papers, for creating very effective content. You will be able to work on it. Okay, I will show you some demonstrations. So 2 to 3 tools I will show. These libraries I will show in live demonstration mode. One is SUMO, CupCarbon, and Eclipse Mosaic with different examples, so that you will be able to do your research work very easily. So you can see that CupCarbon, very first tool we are covering today, that with live demo, that is CupCarbon. How many of you have used this tool, this IoT based platform, this Internet of Vehicles based platform, IoT IoV? In chat, kindly write yes or no. Anybody already aware with this tool, with this library? CupCarbon. Okay, Sanskrit window available, and you can see. So we can download this software. You can see that it is integrated with agentic AI. Okay, it is compatible with recent emerging technologies, agentic AI. You can see that agentic AI, large language models, RAG, these are available. So if we want to simulate something and we want to use Chat GPT, we want to integrate Gemini Copilot, that can also be done. Okay, Cup Carbon, K lines, and by which way we will be able to work with it. So its complete documentation is available. You can see that as far as programming interface of Cup Carbon is concerned, it is working on Python as well as Sanskrit. Okay, so you can see that this one, if I want to integrate it with ESP32, that is also available. So this one, ESP32. So in this way, we will be able to record data. We will be able to put some particular locations. If we want to specify some longitude, latitude, that can also be done. Now, this software I have already downloaded for Internet of Vehicle based implementations. I will show you some demonstrations. Okay, I am loading this software. So when you will download this software, it will be available in zip format. So you can see that this is Cup Carbon. Okay, and Cup Carbon K lines. So you will be able to download it in zip format. When you will extract it, you will get this cupcarbon.jar file, and it is a Java based software. So you will be able to work on it. So you can see this is the working panel, this is the working dashboard of cup carbon simulator. Okay, and you can see that most of the implementations, most of the coverage, most of the scenarios we can create in minimum lines of code. You can see Python is also there, Sanskrit window, Python, that we will be able to integrate. Okay, now new project. You can see network information, number of sensors, base stations, devices. If we how many devices we want to integrate, script file, GPS file. Okay, radio parameters. On which radio parameter you are working, 802.15.4 or Wi-Fi or LoRa, any you will be able to take. Okay, so in this way, now we are creating one new scenario. So new project. Okay, on desktop, this one. Okay, We are creating new scenario, and now we want to put some particular map. We want to give some particular interface. You can see that map, or this is look of Google Map. So at a particular location, we want to specify a scenario. Okay, Google Map satellite. So in real time, we want to capture some particular data at some particular location. We want to put some particular vehicles. Okay, at some specific location, we want to put some vehicles. So you can see it is giving look of Google Map satellite, and this is classical Google Map. Okay, so any location from India or any other location, any other place, we will be able to take. Okay, so for example, in a particular city, in a specific location, I want to put some vehicles, and then we want to simulate it. We want to go for simulation part. Okay, so where we want to put it, so by zooming we will be able to move. Okay, or we can put it in blank with some light. Now this is working scenario. Now we will put some sensors. Okay, once this particular scenario is available, when this particular blank dashboard is available, now we will be able to put some sensors. So you can see on mouse over, you can see this one sensor node. On click, I want to put some sensors. One, two. So you can see that this one. So different sensors will be able to put here. And now if we want to place some, if we want to put some specific line, so you can see that some specific road we want to place. So marker, click this one. This one is the road we are creating. So this feature is not available in ns2 ns3, this type of GUI interface. So you can see this road we have created, this particular location. I want to move some vehicles on this particular road. Now what I will do, I will select this particular line. So you can see that on mouse over, we can check select or all sensor nodes, or select all markers. Click, simply press U. Now on press, by pressing U from keyboard, we will be able to place milestones. So these are milestones. If I want to change it, for example, here I want to move this particular point, this one. Okay, at any point we want to change it. Now this particular location we have placed, we have created, corresponding to this location or corresponding to this path where my vehicles will move, I want to create a GPS file. Obviously, if we want to move a particular vehicle on this path, this file, this particular file should be available with longitude and latitude. When we move, when we drive somewhere, you might have seen many times we activate Google Map. So Google Map keep track of longitude, latitude, where we are going, whatever is the congestion free location. So what we will do, so in this marker parameter, you can see that this file we are creating, file name is route1.gps. route1.gps file we are creating, city 1, city 2. Okay, save. Now this GPS file is created. You can see at the left hand side this GPS file. Now whatever node we will take, for example, one mobile node we are taking. Okay, sensor node. Okay, or some particular mobile node, this one. Okay, mobile, this particular mobile node we will click. On mouse over, you will be able to see. Now this is my vehicle. On click, okay, simply click here, and after clicking, we want to place, we want to move it to a specific path. So you can see that, so I'm zooming it. So this is our mobile node, and now we want to move this particular mobile node in this path. So on double click, Which GPS file? GPS file is this route1.gps. Okay, this one route1.gps file. Now allocate. Now this particular file, this particular vehicle will move on this particular path, on this specific path. Okay, now we want to place some sensors. This one is your sensor, you can see that sensor node. Okay, now we want to change, we want to increase its range. Okay, so you can see that all of these commands I have given in this presentation, by which way you will be able to change these ranges. Okay, so you can see that increase radio area in, or shift plus. Okay, so with this one, okay, this one is your base station. Now we want to create one GPS file. Okay, GPS file, this particular file is already created and we have allocated. Now we want to create one Sanskrit file. Okay, so this is Sanskrit file. So which type of file we want to create? For example, loop. Okay, so I will show some realistic scenario also, so that you will be able to work on it. Okay, so save. Now this particular base station you want to allocate with a script file, this one, and then you will be able to work with it. Okay, so some realistic scenarios I have already created, so that you will be able to work with it, and then from that particular code I will show you, uh, I will explain each and everything. Okay, so that you will be able to understand the scenario. So this one is the scenario. For example, this particular Google Map scenario we have already taken. Okay, standard 1, standard 2. Now we want to execute this, so by which way it will give us the it will provide the output. Okay, so this one is simulation parameter. Okay, visibility, log files, run simulation, for how much time we want to execute it, and by which way this particular mobility will be presented. Okay, if we want to see its log file, whatever output is there, we want to view its log file. Okay, so I'll show you some demonstrations on this software, so that you will be able to see its look and feel and log file analysis. Okay, for example, this particular code and this mobile node in results. So this is simulation result. Okay, in case of ns2 ns3, you might have seen that we collect data from tr files. Okay, some particular files we have to uh, fetch with some gawk commands or with some linux commands, we have to fetch the details. But here you can see that corresponding to some particular timestamp, data is collected corresponding to some specific sensors. Okay, so for example, I'm taking one scenario in CupCarbon and mobile nodes. And this mobile node, you can see simulation parameter, symmetric visibility, we want to view it, log, and we want to execute. So you can see that in this way. So in very professional, in very effective way, we will be able to view results. So you can see that multiple base stations are available. So four base stations we have taken. These four base stations are communicating with each other, and this is a drone. This is a drone or suspicious vehicle. As soon as this particular vehicle will come in range of the base station, uh, this particular color, you will see that this particular message will be changed. Okay, as soon as it will penetrate that radio area. So you can see that now this particular message is changed as soon as it is penetrating that radio area, that specific range of base station, so that some preventive measures or some decisions can be taken. So you can see that in this way. So I'm zooming it. So I will execute this code again. So and I will explain. Okay. So these are four base stations. So by which way these four base stations are created? So you can see that this is first base station. If I want to increase or decrease its range, you can see that this one minus. So in this way. So now it is communicating with this one. Okay, another base station. This is second base station. If I want to take one more base station, so you can see this one base station. On click, I will put here. Okay. If I want to put this base station in this range, so now this base station will be in range of all of these. Okay. So in this way. Okay. So any number of base stations you will be able to put corresponding to each base station. There will be a particular script file. Okay, so what we have done, first of all, we have created this particular path with marker. So this is marker parameter. This path we have created. This path is associated with a GPS file route1.gps, and this vehicle will move. Now as soon as this particular vehicle will move, so okay, I'm zooming it. Okay, we are opening that again. And once it is loaded, then I will show you some scenarios. This one IoT robotics and mobile nodes or mobile routers. So this one. Okay. Now zoom. So you can see if I show you these scripts, by which way we create these scripts. So this one is script editor. So first script is R1. Okay. So you can see read X. X means whatever data it is sensing. Okay, as soon as it will sense some particular data, it will send a specific signal. In same way, if you want to see for router 2, so this one sending signal. Okay, or carbon mobility. Okay, so this specific scenario, so any type of scenario will be you will be able to create. Okay, any type of uh, design or any specific formation you will be able to create. Okay, for example this one. So on zooming, now a vehicle will move. As soon as that particular vehicle will come in a specific range, then particular action will be taken. So this is mobile node, this is your vehicle. Now if we execute this, so log file results visibility run. Now you can see that as soon as it will come near to this specific range, so you can see detection router 1, router 2, or base station 2. Specific action can be taken. Now if we want to work for some large scale scenario, some smart city based scenario in which multiple locations are associated with each other. Okay, complete grid, smart grid based application. So many locations, multiple cities, multiple points are interconnected, and onto that we want to see the results. Okay, on that specific scenario we want to see a particular outcome. So this type of design. Okay, mobility, and this one. Okay, any type of uh, formation of base stations and this particular smart vehicle can be integrated. So if you want to see, so you can see that as soon as it is in a specific range, in that then it is highlighted and it is detected. So detection, and it will move that specific signal to remote base station. So either, so if we want to integrate AI with it, for example, I want to work with AI based application, we want to integrate LLM, we want to integrate MQTT with this, so that is also possible. So for that we will use K-line, so that is latest version K-line, that is available with MQTT protocol. So IoT, AI, and generative AI based applications, agentic AI based implementations. Okay, so this one you can see that. So for example, I want to put some particular blocks. So new project, this one. Okay, here we want to put some sensors. So these are sensors. Okay, now select. You can see we will be able to change it. If I want to change these sensors, so on click of J from my keyboard, so you can see which type of sensors I want to integrate. For example, I want to take n number of sensors. Okay, this one, and these blocks we want to modify. So some drones, for example, some aircrafts, and some cloud servers, some drone applications. So in this way, now corresponding to these we want to create a scenario. On click of J, so we want to put some webcam or some specific chips. Now we will take some webcams. Okay, these are few webcams. Okay, now we want to link it. Okay, some webcams, these drones, and we want to link it. Now if we want to put some MQTT broker, we want to place some broker, we want to place some particular uh, communication protocol. Okay, so you can see that in same way, some base station, sensor node. Okay, directional sensor, marker. So which particular marker we want to take for movement of vehicle? This one. Okay. This we want to take in form of a car. Okay, on by pressing J from keyboard. So all of these I have given in this PPT. I will share this PPT to all of you. Now double click, select all markers, press U. Okay, this now we want to create a file. Okay, this GPS file we want to create. Route 1, route 2, save GPS file. Now this particular car we want to run on a specific GPS file. This one is GPS file. Okay, and we want to execute some code. Okay, so you can see program, which program we want to run. Okay, for example, hello world. Okay, just for demonstration, add the extension py, save. Device parameters, script parameters. Okay, and we will be able to execute it. Okay, some more scripts we will be able to add. So some certain scenarios we are taking. This one. Okay. Simulation parameters, visibility, results, logs, and you will see the data communication. Okay, simulation running at top, and whatever communication is going on, it will be recorded at backend. It will be this particular CSV file will be available. So end of simulation, and we will be able to see that particular file. So one more simulation we will see how to execute, and then we will check its file. Acknowledgement, and now you can see send one. So whatever message is sent, so received one. So I'm zooming it. So whatever message is sent from here, it will be received in light. So here it will be more clear. So you can see send whatever message is sent, it is received, and its log file will be created automatically at the backend for analytics of data. So if you want to see its log file, how much by which way this particular communication is taking place, and how to analyze that particular log file. So this is the evaluation part of log file. Okay, so columns, these are sensor nodes. So S3, S4, S6, S7. So in this way you will get that particular file. Now we want to see that specific file. So this one, simulation.csv file, we want to evaluate. If we want to plot these results, it can be done on some more scenarios. a line. So for example, get info. So information of some specific nodes. Okay, standard. This is white, and we want to modify visibility, log files, results, and so you can see this one. GPS location, real-time GPS location we are accessing in this way. So longitude, current latitude, and GPS location. So in this way, and whatever results you are getting, it will be stored in a CSV file, and this analytics we can this particular result set we will be able to plot. Okay, meaning of CSV file. Okay, sensor nodes, and what about energy level? So if we are working on energy efficiency, if you are working on power efficiency, okay, so energy levels, so whatever parameter we have set, so time what is, so if you want to see how much energy is saved, how much energy is left, so that we can calculate from this CSV file. Okay, in same way, if we want to go for some scenario related to some MQTT, okay, or hello world or blink, so multiple scenarios are created for demonstration so that you will be able to work on it. Okay, if you want to see its script file, so this is publisher dot uh, py. Okay, so here we are using broker dot hivemq.com. Okay, here you can take mqtt.com. In previous session we have seen by which way we have to put these credentials. So broker.hivemq, so 1883, which topic we are accessing. This is the cup topic, okay, cup carbon topic, and which message we want to transmit. Okay, if there is some password, some credentials will be able to put. For subscription, in same way, broker.hivemq.com. So what we are doing, we are taking multiple vehicles, multiple blocks, and those vehicles we are able to communicate, we are able to interface with MQTT and remote data transmission. For example, this one, and visibility, run. So whatever message will be sent from administrator, it will be received by other nodes. Okay, so you can see send one, and so this is received zero. Okay, so send zero, receive zero, send one, receive one. So whatever message will be sent from administrator, it will be received at specific end. Okay, and that particular block will be highlighted. For example, we want to change this one. So in blinking format, if you want to see, so that clearly it will be visible whether zero is received or not, or whatever message is received. Okay, so this one, so run, and Now whatever message will be sent, it will be received by end nodes. So you can see this one. Whatever message is sent from this to remote devices to remote vehicles, accordingly that action will be taken place. Okay, and its CSV file will be created. It will be generated automatically at the backend, that we will be able to see. Okay, now if we want to put some environmental factors, so you can see that this one, energy consumption. If we want to go for an energy consumption graph, if you'll execute it for long time, then this graph will be created automatically, energy consumption graph. Okay, this one is related to natural event generator. Okay, many times we have to generate random environmental factors. For example, environmental environment. Okay, so we want to generate n number of temperatures. Okay, some environmental factor. For example, a vehicle or n number of vehicles are moving at a particular location. We want that, because in every location, weather situation or weather condition is different. We want to integrate that part. Okay, save. Now this is weather. Okay, this weather we are integrating here, and this particular weather will be attached with a weather file. Okay, natural event file. This is environment.evt. Okay, now whatever vehicles are there, they will move from one location to other location, and depending upon changing weather conditions, their behavior will be changed automatically. Obviously, in different temperatures, in different humidity, its outcome will be different. Okay, so for example, for this one we are executing, and depending upon this environmental or weather condition, its outcome will also be modified. Okay, so in this way. So this is one platform, that is CupCarbon, that you can use for simulation of IoT scenarios. If you want to work with SUMO simulator, very powerful simulator, SUMO simulator for Internet of Vehicles, Internet of Things, in Internet of Things based VANETs, then you can use this one. One very classical demonstration I will show you related to this part. Okay, simulation of urban mobility. Okay, so this screenshot I have given in this presentation, by which way you will have to work. Okay, now this particular platform provides real time interaction with some with particular locations. Okay, some specific location, some specific GPS location I want to map, and on that we want to get some simulation part. Okay, we want to simulate a scenario. Okay, so you can see that this one is the path from where we will execute it. So first of all, I'm closing it. Okay, Eclipse. Now a particular file, Python and OSM web wizard. So one interface will open. So this is your, it is connected with our sumo simulator. So you can see for which location I want to see. For example, I want to map a location Chennai. Okay, so this one. Okay, so you can see that. So in Chennai, in some particular location, in some at some particular crossroad, we want to put some vehicles. We want to simulate a scenario. Okay, so participants who knows who were aware with this location, they might be knowing better about these places. Okay, now here we want to simulate some scenario. Okay, so you can see that car only network. I want to fetch real time data, car network, satellite background required or not, import public transport. I want to fetch. Okay, now search. Okay, select area, this one, select area. Okay, which particular location? So only this part I want to take for my simulation, this particular part. Select generate scenario. If I want to create manual scenario, I want to create my own implementation, my own network, that can also be done. But currently we are taking from real time data, from real time data from satellite. So you can see that this is created. So this is the location which we have fetched, and corresponding to this location, this sumo file is created. So you can see that this is same, exactly same location is extracted, and if I want to simulate it, that can be done. How many vehicles we want to show? Okay, so currently you will not be able to see any vehicle. When I will run, then you will see multiple vehicles here. For example, this 90, and the real world, now I am running it. Now you can see that in real time how many vehicles are there, and what about the scenario. So you can see that this one. Okay, if you want to see, if you want to take any other location, for example, I want to take for Bangalore. Okay, search this particular data, this particular location we want to fetch, and corresponding to this location we want to simulate. Generate scenario. Okay, I if I want to create my own network, that can also be done. Now it is converting to map. So first of all, I'm removing previous data. Now once it is generated, then automatically it will open in Sumo simulator. So processing cars, processing public transport, and then it will be opened. You can see that now this is opened. So now this is same location which I have identified. So from corresponding to this location, to this particular plot, it's corresponding sumo scenario is created. This is sumo cfg file. Okay, now if I want to execute in real world, so different roads, different vehicles. So you can see that this one, so many vehicles, real time data, so we can see how much congestion is there, or whether it is congestion free or not. So if we are proposing some algorithm for congestion free network or for congestion control, then on this scenario we will be able to create, we will be able to propose some algorithm. Are you able to view the vehicles? Kindly confirm whether these vehicles are visible to all of you. Very small cars. So we, because we have enabled public network. So you can see that this one, at which at different cross points, crossroads. Okay, so you can see trains, different, even metro, even different public transports, these are also mapped. So if I want to put some, if I want to implement some machine learning algorithm, some deep learning algorithm, that can also be done, okay, on this particular data. If you want to implement a deep learning or machine learning approach. Okay, in same way, so satellite background and generation of scenario. So if we want to work on some machine learning, deep learning based scenario, in that, then we have to uh, integrate in Python script. Okay, so in JSON, so whatever file is available in JSON format, whatever file is available in XML format, we will parse it, and on that we will be able to implement. So some scenarios I have created related to machine learning also. So I will show you. So you can see processing of cars, generating scenario, and automatically it will open. Okay, so this one. Okay, now on this we want to simulate 50 or 90, and you want to go for execution part. This is real world rail network. So in very professional way we will be able to present our work related to simulation. Okay, sumo simulation. So if I want to create my own simulation scenario, then we work in net edit. So you can see this is net edit. So rather than this Google map, I want to create my own implementation. So net edit, new network. So net edit is connected to sumo simulator. So this one, so one network I'm creating, edge connected. So this one, so this road we are creating here, this specific network, similar to CupCarbon. Now demand. Okay, we want to put some vehicle mode, where this vehicle will move on this particular path. This vehicle will move. If we want to put some script, like we want to specify ant colony optimization, particle swarm optimization, regression on data, on real time data analytics, we want to go for plotting, that can also be done. Okay, finish route creation. So you can see finish route creation, now it is created, and this one vehicle we have created, its route is also generated. Now edit, open in sumo. Okay, so first of all we will save it as one. Okay, now this network that we have just created, on this network we want to execute. So you can see 60. Okay, so it's up to you whether you want to in this way, or you want to use a particular scenario that we have seen in case of open weather map, that OSM wizard. Okay, or from Google map. So both options available, either with Google Map or with our own scenario. So it's a complex network can be created depending upon our requirement. For example, so this is same. If I want to modify this specific scenario, so this is edge chain. Okay, one edge chain we can take. Okay, this is edge traffic mode, traffic light mode. If we want to put traffic lights connection mode, okay, so you can see show grid edge chain. So we want to create this type of network. Okay, very complex image, very complex uh, route we want to create, and on this particular route we want to move a specific vehicle. Okay, now demand some specific car vehicle mode or pedestrian, it will move to which particular location. Finish route creation. Now we will see whether there will be congestion or not, whether there will be collision or not. Edit sumo GUI, this one, real world. So that uh, route we have just created. Okay, okay, or 400, whatever it is. Now we will see whether there will be instance of collision or not. Okay, so if we want to control this particular collision or we want to control this specific congestion based scenario, then we can check. Okay, we can create some over bridges, some flyovers, some specific scenarios. So each and everything can be created. So either with this one or with Google Map, real time Google Map, this one. Okay, with Mosaic also you will be able to work in same format with Eclipse Mosaic, that also provides you this type of interface for real-time mapping of traffic, dynamic mapping of traffic. You will be able to put base stations. We can integrate our algorithm. Okay, so scenario will be generated, and then whatever algorithm we need that we can specify. So this one. So this is Sumo simulator, and now you can see this one. Now, if we want to attach deep learning, machine learning, data analytics, that is also possible. We can integrate with it. Okay. If we want to link it with machine learning, with deep learning based approach, that can also be done. So, some scenarios I will show you. For example, I want to implement encryption or machine learning regression. So these codes I have already created. For example, I want to integrate this machine learning. Okay, so you can see that this one automatically graphs will be plotted. Okay, it's by which way we have to execute it. So some certain implementations that you will be able to execute. Okay, so simply the generation of network in same way, and then After coming to that scenario, that location, so where is this particular code in sumo sumo ml regression, and now run ml. Okay, ml code. So whatever, so this one is the script for machine learning for regression that we have, that is coded. Okay, and onto this scenario it will be executed, and we will get that specific implementation. We will get the required output. Okay, whatever plots we want to generate, it will be generated. Okay, if we want to put some specific, we want to place some specific graph. So you can see that this one, now simulation is running. So this output is taken from sumo. So this graph machine learning from speed position. So real time, in real time it is capturing data. Okay, at one time simulation is running, and this particular graph. So if you want to go for some accuracy, some specific error factor, some specific confusion matrix we want to generate, that we will be able to do it. Okay, so within this particular code it is written. Okay, so you will be able to work on these very effective scenarios for research work. Okay, automatically we will be able to get graphs if we have coded with python. So we can link it with python, as just now we have seen in this way. Some graphs, some plots we will be able to generate. Whatever output is there, along with that we will be able to put some graphs. We will be able to generate some plots. Okay, on a specific simulation, on a specific implementation. Machine learning based prediction of speed from specific position. Okay, from current speed we want to see what will be the upcoming scenario. So in this way you will be able to explore these platforms. The major part is that rather than sticking to ns2 ns3 or classical simulators, we can adopt very high performance simulators like Sumo, Eclipse, Mosaic. Eclipse Mosaic is also available. So you can see Eclipse Mosaic. Its tutorials are available, are given, and completely free and open source. If you want to simulate these scenarios, intelligent connected vehicles, electric mobility, and so on. Now, dear participants, I am sharing this presentation to all of you, in which some in which all of these resources are given. I am sharing this presentation to all participants so that you will be able to work on it. In same way, I am uploading it on cloud, and if you have any query, you can ask. I am uploading this presentation on cloud link, Smart City, IoV, and this link is ready. Now, dear participants, link of the presentation is given in chat window. Kindly confirm is it downloadable or not. Simply click on the link given in the chat window and download.